Here's a 12-volt car battery and a solar charge controller, an older model, PWM pulse width modulation. The positive of the battery is connected here to the center part, to the left one, and the negative of the battery will be connected to the battery. And that happens. So I'm touching and untouching the negative on the battery. So when power is received, that red LED turns on. Now a voltmeter is connected here to the right side of the charger, the plus output and the negative output. Okay, and it is set to 20 volts DC. And if I connect the power here to the middle, plus and minus, then the 12 volts of the battery will exit here on the right side also, and 12 volts will be visible. So I'm powering here the center, and it exits on the right side, 12.27 volts. So as you give power to the two center pins, power automatically exits here. Let's insert these leads, not here to the right side, but to the left side. Okay, 0 volts. Now if I power the center two, let's see, will power exit also at the first two where the solar panel should be? No, it's not exiting, 0 volts. Now I moved the power from the center to the first two, so I'm giving power to the solar panel's input. I'm giving it from the battery. Let's see, will power exit at the battery side? It should exit. So I'm measuring voltage. A very small amount exits, 0.6 volts. And the white LED turns on. Once again, 0.6 volts are exiting at the battery. And when I power it at the solar panel side, there is no click sound. Relays don't turn on. Now let's move these to the right side, where the load should be. So we are powering with electricity the solar panel side, and let's see what voltage exits at the load side. Also 0.6 volts. So let's check the voltage of this battery. It's 12.2. So now I'm powering it at the solar panel side with 3.4 volts, and the LED does not turn on. Let's increase the voltage. So somewhere at around 6 volts it starts turning on, and I can bring it up to 25 volts and it's still on. It looks to be functional, it's not burning out. So I'm powering it at the solar panel side. I plugged in the multimeter, and if I power it with 12.8 volts here at the solar panel side, it outputs to the battery 0.6 volts, and that's a weird number. If I increase it to 15 volts, it's a 0.7 volts. At 24 volts it doesn't even output 1 volt at the battery side. Now the circuit is complete. We have a power source as a solar panel, we have the battery, which is there, the black wire, and we have a load, which is just a multimeter. Okay, so let's connect the battery. When that is connected, that red light comes on, and power here on the right side is right away available. Okay, and now if I connect the solar panel, then the white light also comes up, and if the voltage is too low, white LED goes out, let's say the weather is cloudy, you don't have enough power from your solar panel, battery voltage drops 54, 53. Okay, sun comes out, goes to higher than battery voltage, let's say 13. It was 5, now it's 7. So battery voltage is increasing, 8, it's increasing. And if I go higher, it makes clicking noises. So at around 16.5, so if your solar panel gives too much voltage, it cuts off power and it's making that noise. Lower voltage, no clicking sound. Higher voltage, clicking sound. And voltage is dropping. So if you're using a 12 volt solar panel and it gives 16 volts, that should charge your battery. So output power varies with the amount of sunshine. Higher voltage here, higher voltage there. It goes up. A lower voltage from the sunshine, lower voltage here at the output. Higher. Lower. Let's see what will happen if I want to charge the large battery with this small adapter. It's rated to 2.5 amps. So the multimeter is set up to measure amps. It's here. This was moved up here instead of there to measure amps. Okay, and from the adapter we have the plus going directly to the battery, and the minus goes through the multimeter and exits on the other lead of the multimeter and goes to the battery. So power goes from here to there, and just one, the negative, is interrupted by that multimeter. The multimeter is in series with the adapter and with the battery. Okay, and if I put the power there, it's measuring 0.2 amps. So this gives roughly the same voltage as the current voltage of the battery. And if those two, the voltage of this one is kind of equal with the voltage of that one, then you have a tiny amount of current flowing, 0.2 amps. Let's fix this somehow. Okay, now I fixed that wire somehow there. So, if the voltage of this one is equal with the voltage of that one, you should have 0 amps flowing from here to there. If the voltage of this one is higher than that one, than of that one, let's increase it, then the amperage increases. At 13 volts it's already consuming 1 amps, so I'm charging the battery with 1 amps. At even higher voltage, let's say 14 volts, I get 2.7 amps. 3.7 amps at 14. Okay, let's don't overdo it because this is not powerful enough. Okay, but what if the voltage of this one is lower than the voltage of that one? Well, in that case, this should turn from positive amperage to negative amperage. That is, the voltage will not go from here to there, but from here to there. I'm reducing it and it's negative. And it's not going lower than that number. This is basically measuring the voltage of that one. If I disconnect the battery, let's say from here, then it goes down to 3 volts. Because this gives 3 volts, but if I connect the battery back, then it's sending the 12 volts from here to there. Positive amperage, negative amperage. So we're charging the battery with 0.7 amps. Let's see if I increase the voltage even higher. Oops, 5 amps. 5 amps. It's not giving more than 5 amps. Wires are not hot. The voltage is not increasing either. So it should go up to, let's disconnect it. It should go up to 25 almost volts. Okay, and instead of almost 25, it goes up only to 16 volts. So although it's pushing 5 amps, voltage remains lower to 17. Let's don't kill it. So now I'm inputting here to the left side less voltage than the battery voltage. This is measuring here at the output. So when the input voltage of the solar panel is less than the battery voltage, then the output voltage is positive. And when it's higher, the input is higher than the battery voltage, then the output is also higher. In case of the amperage, when the input voltage is lower, the current goes negative.